Okay. So you look at the numerator, multiply brackets and simplify. Look at the denominator, multiply any brackets. You're just focusing on the denominator, try to simplify. Try to bring everything together, not have multiple x's or multiple y's or multiple a, b's, whatever. You want to bring it all together. Then you're going to try to simplify coefficients. That's a fancy way for numbers, right? Right, simplify any numbers that are there, like the fractions. If you have a number in the denominator and the numerator and they have a common factor, you do that, right? You simplify it. Collect common basis using, right, x top minus bottom, right, y top minus bottom, right, and that continues, right? Like, so you're looking between the numerator and denominator, okay, and you're doing this after you have cleaned up the numerator and denominator, and then you want to eliminate negative exponents, and you do that, right? Flip. If you ever have a base with a negative n, right, you're gonna bring it down if you need to, and vice versa, right? If you have a negative in the denominator, we bring it up. Six, apply the outer exponent last, okay? So that's going to be the very, very outside, like if everything is in brackets, you have a whole bunch of stuff inside, and there's an exponent on the very outside, you do that one last, okay? So to give you a visual of what you might encounter, this is like full-blown example, right? Let's say you have things multiplying in the numerator, you have things multiplying in the denominator, right? And it could be even that within these little guys you have like exponents here everywhere, right? So you have to make sure you take care of that small bracket first, of course. And then on top of that you have like an exponent out here, for example, right? And you might have a number in front and another number in front here. It may be positive or negative, it doesn't matter. So you first take care of the numerator, then you take care of the denominator. You can multiply across, clean up everything. And then you look at up and down, right? That'll be step number 4. 5, eliminate any negative exponents, and then apply the outer exponent last. So this would be inside, right? And this is the outside, like this one right here, outside, right? And this is the inside. So first you got to clean up everything inside, and then at the very end you apply the outside exponent. Okay? So this is in a nutshell how I'm going to approach things. It's basically the same way as factoring. And I can tell you this, that everything in this unit is connected in some way, shape, or form. Just like factoring, at the end we bring it all together and we apply everything we've learned The radicals, like entire to mixed, that's kind of like its own little category, but everything after is going to be like this. Okay. All right. So more examples. So we're going to go a little. I'm going to give you some tougher examples today. Not at first, but we're going to get there. So we have A here, examples, right? So these are the one-liners, okay? So it's just all multiplying, right? So we're gonna kind of just start slow and then increase from there. So one thing that I noticed when we were doing expanding and simplifying, remember those polynomials? There are no polynomials here. These are it's just expression, right? So no polynomials, but don't do, like I've seen a lot of you go 2, right? 2c, you'll multiply 2c times this, and then you will take the 2c and also multiply it by this. It's like that's not correct. That's not mathematically consistent, and I'll show you why. Let's say you have 2 times 5 times 4, right? And I think on the test correction I talk about that. 2 times 5 times 4. We know that 2 times 5 is 10, times 4 is 40, right? I think we would all agree with that. If you go 2c times this and then 2c times that, it's essentially as if you're saying 2 times 5, right? And then 2 times 4, right? And this would be 10 and 8. That's 80, right? And that's wrong, right? This is not right. So whenever you have things multiplying, you're not distributing it amongst everything that's behind it. It's just right next to it. And then you get an answer and then take that and multiply it by that, right? Like it's like a chain reaction. Okay. And so what we're going to do here is apply, this thing needs to be done first, right? When there's a power, you can't just treat them all the same. You have that little exponent there. So that's power of a power. So we need to apply that. So this negative, I'm going to actually make it -1 squared. And that's b 2 times 2. Sorry, that's an a. A, right? A 2 times 2. B 3 times 2. C 1 times 2, if you want to look at it that way. Right, and I'm going to put that in brackets like that, and I'm going to copy down everything else because I don't want too much here. Okay. And then let's figure this out. -1 squared is just +1, right? So I can put a positive here, and that's a to the 4, b to the 6, c to the 2. 3ab squared c4 2c. Now none of them has an exponent other than 1, now I can clean it up. So you apply the same thing to a bigger example like here. Like let's say this would have been part of the numerator in a big expression like this that has a denominator, you first have to take care of that. And I won't always go in that much detail down the road, like I'll just do it fairly quickly, but I just need you to have this written down. So now we can multiply all across, right? So number 1 times 3 times 2, that's 6. A, right, it's 4 plus 1 plus 0, right? B is 6 plus 2, and no, there's no B on the last one. C, 2 plus 4 plus 1. So you're adding all the exponents because that's what we do when we multiply like bases. So that's 6, a to the 5, b to the 8, c to the 7. Okay, and that's your simplified expression there. What about negative exponents? So just so you know, we could have something like this in the numerator, and I could have thrown something like that up here in the denominator, right? And then you had this big expression, but now we're just sticking with one line for now, and you'll see how that's going to change, okay? So you have something like that. You should notice that I can't just multiply across. I'm going to do this first, okay? What you could do is already multiply these two together in your next line, right? So you're not wasting too many lines. So I'm going to go negative 10 x cubed, y is just y, z to the power of 6. Okay? So you've cleaned this up, so you're there. And then this, negative 3 squared is just 9. Okay, right on your back though. 1 second, guys. I want to make sure this works out the way I want it to work out. Yeah, we're good. So negative 3 squared is positive 9, right? Watch that. And then x 2 times 2 is 4. Y negative 4 times 2 is negative 8. Uh-oh, we have a negative. Don't like negatives, right? It's all good. We're going to go negative 10 times 9, that's negative 90. X to the 3 and x to the 4, that's x to the 7. Y, here I'm going to watch out. Y is 1 minus 8, right? Because it's 1 plus minus 8, which is just 1 minus 8. And z to the 6 stays because there's no other z here. And here it gets tricky. It's negative 90, x to the 7, y to the negative 7, z to the 6. And I don't know if you remember my steps here. We don't have numerator denominator, so we basically just stick to the numerator. We don't need to simplify coefficients. Yeah, I will check in a bit. Hold on, Lance. Collect common bases, we don't need to do that, but we need to eliminate negative exponents, right? We need to get rid of that. Apply outer exponent. We don't need that because it's not happening just yet. So these steps are there if it's needed, okay? So get rid of, what did Lance say here before I finish the question? Isn't negative 4 squared 16? That would be correct. But, oh, okay. Lance is asking what happened here, right? Is that what you're asking? Power of a power, Lance. If you have a power and another power, it is A m times n. That's what it is, okay? Because y to the negative 4 and y to the negative 4, right? Because that's what y negative 4 squared is really saying this. And if you add the exponents, you get y to the negative 8. Because it's negative 4 plus negative 4, that gives you negative 8. Does that make sense? All right, good question. Okay, get rid of negative exponents. Okay, so I'm going to highlight that. How do you do it? You just literally bring it down, right? You just bring it downstairs. So it's negative 90 x to the 7. We make a line here so that we can bring the y to the 7 down, z to the 6. That is it. That would be your final way of doing that. And that's where practicing is going to make you conquer this, right? These little issues here, isn't it 16, right? Negative 4, if this had been negative 4 Lance and then squared it, that would have been positive 16. That is correct. Because it's technically 3 has an exponent of 1 to it, so you go 1 times 2 is 2, right? So negative 3 squared is 9 positive. Okay, let's do denominator now. What if you have Q6 times Q4 over Q Q8, all of that to the power of 3. This I can do right next to it. So remember my steps, numerator first. So if you multiply numerator times numerator, that'd be 6 plus 4, right? Nothing happening in the denominator. For now, I will just leave it. Okay? I rewrite this. I would encourage you to rewrite as many times as you have to, just to show step by step, right? You've taken care of the numerator, you've cleaned it all up. The denominator didn't have anything, so you just kept on rewriting it. Now, are there any coefficients that you need to simplify? No. And now we're gonna take care of these, collect common bases. So it's Q10 minus 8, all of that cubed. And that happens to be Q to the 2 cubed. And that's Q 2 times 3, which is Q6. Done. Let's see if you can could do something like that. Give that a try. See if you can do that. Doesn't matter what you get right now. It's the process, right? See if you can do that. Just try D for now, okay? Exponent laws on a Friday is just the best mix, right? Like you're all excited, you can see. Okay, if you want to go, if you want to do this faster, that is fine. And maybe I will show you if there's room, I'll show you how to do this a lot faster than the way I'm doing that right now. But if you want to stick to my steps, right? There's something happening in the numerator. So we go 3, it's really plus, right? Because you're adding when you're multiplying like this. It's 3 plus -2, and we know that's just going to be minus here. And nothing happens here, so I'm just going to do this for now. 3 minus 2 is just m over m4 squared. Any coefficient that I need to clean up? Nope. So now I'm going to combine like terms, looking up and down, right? So it's 1 minus 4, right, squared. And that is 1 minus 4, right, is -3 squared. What happens now? Get rid of negative exponents. So we're going to do this. Like that. Right? If you want the negative to be gone and there's nothing, right, then you just go 1 as a placeholder and you bring the m to the 3 down. Okay? And now you apply the power of 2. 1, right? 1 squared is just 1. M squared is just 3 times 2. That's m to the 6. That's your final answer. Okay? If you wanted to do this faster, you could have gone, these have all the same base. Therefore, if you just see that that has 3 plus -2, because they're multiplying here, and you'd have to subtract whatever exponent is at the bottom. All of that squared. 3 minus 2 is -1. sorry, 1 positive, minus 3 is negative 3. If you wanted to multiply these, that's m to the negative 6, and then you just flip it like this at the end. You still get the same answer. Okay, so this is one method, and this is the alternative method, because we're just making sure that when they're next to each other, we're adding, and when the same base is in the denominator, we're subtracting. Okay, so that's important to remember. Now, right, this is a double Big Mac, right? So we're going to see if we can tackle that one. Looking at my steps here, there's definitely stuff happening in the numerator. So I'm just going to focus. And I'm going to check, do each of them have like a little exponent? No, right? So that's something you need to make sure you watch out for. So I can just multiply across like this. So negative 3 times 2 is negative 6. X to the 4 and x is x to the 5. Y to the 2 plus negative 3, right? So it's 2 plus, because you're adding, they're multiplying this way, minus 3. So that would really give you a negative 1, like that. So you've cleaned this up to just this. That's beautiful, right? And then you have 27, x, y, 4. Nothing was happening in the denominator. There were no brackets or anything like that. So I can just say this is going to stay like that. Now, I cleaned the numerator. I didn't need to do anything here. I simplify coefficients. I know that 3 goes in here twice. 3 goes in here 9 times. Right? I got rid of my coefficients. Now I'm going to collect common bases. And when I say this, maybe in your steps, that means like you're going to go look up and down like that. Okay? And so next here, make sure you have the negative. Don't forget the negative, okay? And I don't have the 9 here, so I do have a fraction anyways. I might as well draw my line like that. X and X, right? So you go X top minus the bottom exponent of that same base. And then watch this, it's going to get tricky. This is where your integers, right? Top minus the bottom, which is 4. And all of that squared still. Don't forget that. I'm going to get rid of my sticky here. I'm just going to clean it up and rewrite it nicely. So this is 4. Negative 1 and negative 4 is negative 5. And in the denominator, I have my 9. All of that's still squared. I'm going to go look at my sticky again. Eliminate, I collected common bases. Eliminate negative exponents if you have any. So let's clean that up. So the negative 2 is still there, x to the 4, and at the denominator you had the 9, and the y to the negative 5 comes down positive. All of that squared still. Now you've cleaned it up. Now you apply that outside exponent one at a time. So negative 2 squared is positive 4. And when you have one of these with exponents, you just multiply the exponents. Don't square it, right? Don't go 4 squared is 16. That's wrong. Okay. 9 squared is 81. And then y to the 5 is just 5 times 2, which is 10. And there you have it. All done. Clean, simplified. Can't get any further than that. All right. I think I'm going to leave it at that. I gave you a lot, I know, and some of your heads are spinning. And that is normal, okay? But you don't want to give up, okay? Don't give up. Continue working. The textbook doesn't have a whole lot of examples. So I'm going to post this worksheet that I just made up, and I'm going to post the answer key as well. And unfortunately, one I already have the answer on there. So anyways, just don't look at it, just do it and pretend like it's not there. So the homework is worksheet, right? This handwritten. Plus, if you haven't done that yet, I think yesterday I assigned page 221, right? Some of you are like, I don't know, because I didn't do it. Please do it, all right? Uh, page 221, all, if you haven't done that, so this is old, right? Plus exponent laws worksheet, right? Which you should also have, right? And last but not least, I forgot that I gave this to you. I never gave this before, but I thought, hey, it's going to save us some time. All of the exponent laws are on this yellow paper, and it tells you what they're called. But the calling of it is relative, like it's not always consistent. That's why I don't like to call it anything. I just like you to look at it and recognize what needs to happen under each circumstance. So you should each have a yellow, right? You do have that, right? If you don't have this yellow, you should have had a green, a yellow, and a bunch of other worksheets there. So make sure you look at them. And let me stop that.